next we're going to be reviewing percent yield, which is a pretty straightforward topic. Basically, we're comparing what we expect to get out of something versus what we actually get. So expectation versus reality. So in the lab, reactions aren't always perfect. We don't always produce the amount that we expect to produce. Sometimes we produce more, but more often than not, we actually produce less than we expect. And there could be multiple reasons for this. Our instruments and measurements could be imprecise. So maybe you use a graduated cylinder to measure liquid. You think that you have exactly 10 milliliters when really you don't. Your scale could be off or not measuring correctly or accurately. There could be side reactions occurring that you don't know about that are using up some of your product or some reactants. There could be spills that occur which would have you losing reactants. If you use old chemicals, usually over time, chemicals do decompose, so you aren't actually adding what you're expecting to add. And there could be contamination that could happen for multiple reasons. So that's why it's important that you always clean up your instruments after use. So if you use a dirty beaker, you might not just be adding water to an equation, you could be adding more products or more reactants without even realizing it. So your percent yield compares how much you actually produce in an experiment to what you expected to produce based on stoichiometry. So before you do a lot of experiments, you're measuring out the amount of reactants that you use based on a chemical equation and number of moles. So you do use stoichiometry before performing an equation or an experiment a lot of the time. So when we find percent yield, we're taking the actual yield, what we actually get when we perform the experiment, and dividing by the theoretical yield, which again comes from stoichiometry, and then multiplying by 100. So your theoretical yield is always determined by stoichiometry, and your actual yield has to be determined by an experiment. A lot of times on test questions, they give you the actual yield. So you're not expected to do an experiment and then do all that. But in the lab, if I ask you for your percent yield, you should be able to determine it. Typically, again, 99.99% of the time, your actual yield is less than your theoretical yield because most of the explanations for why we don't get exactly what we expect lead to a lower yield than expected. So for example, when we bake cookies, a lot of the time you are making based on a recipe. So if you look at Nestle Toll House, I think the yield is 48 cookies. Let's say you make that recipe and you actually bake 39 cookies. You can determine your percent yield. To do that, you would divide 39 by 48, multiply by 100, and you find out that your percent yield is 81.3%. In chemistry, a lot of times you'll get an example like this. So if you have 4.5 grams of hydrochloric acid reacting with 15 grams of calcium carbonate, according to the following equation, what is the theoretical yield of carbon dioxide? So here they give you a balanced chemical equation. This also has in it, kind of sneaky, it has a limiting reaction problem in it. So it doesn't tell you that you have excess of anything. You have to determine which one of these is the limiting reactant so you actually can figure out your theoretical yield of CO2. Okay, so basically we're going to have to figure out how much CO2 we would get if we reacted all the HCl, and we'll have to figure out how much CO2 we would get if we react all of the calcium carbonate. And then we're going to compare those answers, and then the lower of the two is going to be our theoretical yield. So first I'm going to be doing HCl. So if we start with 4.5 grams of HCl, remember my recipe isn't in grams, it's in moles. So I'm going to want to go from grams to moles using molar mass. So that is going to be 1 mole over about 36.458 grams. So again, my grams are going to cancel out. I end up with moles, which is great for this chemical reaction. Next, I want to know basically how much CO2 I'm going to get. To do that, I'm going to be using stoichiometry and use the molar ratio between CO2 and HCl. So I have 1 mole of CO2 produced for every 2 moles of HCl reacted. In the end, I want to know CO2. So remember to cancel out. You want units to be on opposite sides of the fraction line. So I'm going to have 2 moles of HCl on the bottom and 1 mole of CO2 on top. Now, in the end, I'm not going to necessarily calculate or measure my moles of CO2. I would probably calculate volume or grams. In this case, the next problem, which I know but isn't shown here, is going to give you a theoretical yield in grams. So we're going to go ahead right now and do that conversion from moles to grams. So I take the molar mass of CO2 and I'm going to be multiplying by that molar mass. So it's about 44.01 per 1 mole. So I have 4.5 grams times 1 divided by 36.458 times 1 divided by 2 times 44.01 divided by 1, and I find out that that would produce 2.72 grams of CO2 based on HCl. Next, I'm going to figure out how much CO2 I would make with 15 grams of calcium carbonate. So I start with my 15 grams. Again, I have to go grams to mole using molar mass of calcium carbonate. Then I have to use molar ratios. Here it's a 1-to-1 ratio. And then again, I'm going to go from moles to grams by multiplying by the molar mass of CO2. So here I have 15 times 1 divided by about 100.09 times 1 divided by 1 times 44.01 divided by 1. And that tells me that I would produce 6.6 grams of CO2. Since 2.72, that calculation we did in the slide before, is less than 6.6 grams, 2.72 grams is the theoretical yield that we will use for this example of carbon dioxide, and HCl would be the limiting reactant, even though they don't really ask. Continuing that example, let's say we do the experiment and we only measure 2.5 grams of CO2 that are produced. What's the percent yield of this reaction? So now we're going to take actual divided by theoretical times 100. So our actual is 2.5, what we actually measure. Our theoretical is what we got by stoich, so that's 2.72. Multiply by 100, and we have a 91.9% yield. Okay, so that's a review for percent yield. Please let me know if you have any questions.